Hi students, good afternoon everyone. Hope you have written your GATE examination well. Today we have electronics and communication paper. So most of the questions that were given in today's paper are very well discussed in our class with respect to all the subjects. It's not with respect to only one subject. Most of the questions given in today's paper are direct questions. Paper, I should say, it is a moderate level only. It is not a difficult paper. So those students who have written examination with respect to our notes preparation and with respect to our test series, I think they have done very well. So whatever the questions we have today, we are going to discuss it now. These are just memory based questions. So just go through all the questions and see how you have done your paper. With respect to my subject, communication systems, there were around 13 to 14 marks weightage. We feel that 5 2 marks questions and 3 to 4 1 mark questions have come, but that is not sure. That is what the data we are getting right now. So let us discuss each paper. With respect to control systems, sir will tell how much is the weightage and how are the questions given in that paper.
In control system, we got 8 marks this year. All are direct questions, very easy. By looking the question itself, almost you can directly write the answers. So easy questions, easily can score 8 of 8. So next signal sir will talk.
Thank you, Janar sir. Hello everyone. From signals we got around 9 marks, the weightage 3 1 mark, 3 2 marks, but till now we got only 4 to 5 questions. Accuracy we have to still observe. Next network sir, Verma sir and Harmantrao sir will.
Good afternoon everyone. In networks totally till now we got 3 1 mark questions, 2 2 marks questions. They are quite very easy, and my colleague Verma sir also discussed about the question.
Yeah, relatively they were very easy. Only one question came in differential equation. That too I think it is an LTI system. Resonance one question came. Okay, we will discuss that. But overall I would say 4 plus 3 7 marks as of now. We have to see until the complete paper is given. But at the same time I want to add a statement. Accurate solutions will be uploaded once we get the original paper. You can download from internet from our ACE Engineering Academy website. So until then, let us take this data and proceed with the solution. Now I request the mathematics sir and other subject teachers to also talk about their weightage and their importance.
Unlock sir.
Yes, hi dear students. I hope you gave up this exam excellent. So as our colleagues discussed, most of the questions what we have discussed in the classroom, in the test series, yes, we came to know that they came in the exam. And regarding the subject electronic devices, okay, so one question I understand it came from the breakdown mechanism. Next is from optoelectronic devices. Next is advanced semiconductor physics, that is so-called concentration gradient. And one more question, we came to know that it is from bipolar junction transistor. Anyways, dears, so let me transfer mic to mathematics.
Hello students, as per mathematics point of view, as per students information, we have got nearly 13 to 15 marks actually they gave, but we received just 1 to 2 questions only. Detailed information with solutions after original paper will upload as soon as possible.
Hi guys, the questions from digital and CO we got 15 marks, 3 1 marks question and 6 2 marks questions. Questions for moderator, I think mostly we discussed in the class.
Hello students. Regarding analog circuits, most of the questions are on the easy side, and mostly around 4 questions have come from op-amp. That too, all have negative feedback only, and there is no capacitor or inductor involved. They are basic resistors, and only 1K, 2K resistors are given in the feedback. So most of the analog questions are quite easy. Okay, around 10 to 11 marks have come from analog subject.
Aptitude.
Over to aptitude, sir.
Good afternoon. I hope each and everyone did your good job. And from the aptitude, we received only 2 questions, and the way of the question is very lengthy. That's why memory based also difficult. Okay, some of the questions only we are getting from students. Okay, all the best. Thank you.
Yeah, So students, let us start a discussion on each of the subjects. Shortly we will be covering each subject. First we will discuss the weightage with a slide, and then we will be going into each subject. So please stay online and see how we have done your paper today. Thank you. Stay tuned.
Yeah, best wishes, yes. Photo in the.
Hi students, good afternoon once again. So let us see what is the weightage given in this year GATE paper. Approximate weightage, we cannot tell that this is a perfect questions or perfect number of marks given in each paper. So this is what we have seen in today's paper. There is no ambiguity in aptitude. So as planned, it was 15 marks here. So this is perfect, no doubt about that. Apart from that, the first observation in today's paper is weightage in mathematics is little less. Okay, so here you can see very clearly it is around 10 marks here. So this is one difference that we have observed. Apart from this, all the subjects are given almost equal priority. So when you see the networks paper, we have 4 plus 3, 7 marks coming from here. And when you see the remaining fundamental subjects, if you take the control systems, here we have 7 marks coming. And when you take digital circuits and computer organization, we have 12 plus 3, 15 marks coming from here. This is pretty good weightage in this particular subject. And when you take the remaining part, these are the fundamental subjects that we have seen, and in you see 7 plus 15 is around 22 plus 7, 29 marks came from here itself. So this is a pretty good weightage in all the fundamental subjects. When it comes to our core subjects, the signals and systems covered 6 plus 3, 9 marks, and the communication systems covered 10 plus 2, 12 marks. So when you take signals and communication as one part of the core subject, 12 plus 9 is around 21 marks covered from here. When you take the remaining core part, the EDC subject, 6 plus 3 covered around 9 marks, and analog circuits covered 8 plus 2, 10 marks. So it's around 19 marks coming from the combination of these two subjects. So it's a pretty good weightage from here also. And coming to electromagnetic theory, we have 1 plus 4, 5 marks, around 5 marks coming from here. So it's a pretty good division of marks on all the subjects. So those who have prepared fundamental subjects very perfectly and a very good understanding on the core subjects definitely can score a very good mark. So as per our expectation from my side as well as our team, the total faculty team, if you are in a position to cross 50 marks, definitely there is a very good chance that your rank can be less than 1000. That is our prediction from our end. And the paper level that we can say is a moderate paper. It is not a tough paper. some subjects came very easily, some are average. So we can say that it's a moderate paper. So those who have done good preparation, those who have referred our notes, and those who have attempted the test series, definitely there is a very good chance for those students to get very good marks. At least they can score minimum 50 marks in this paper. So that is our prediction in this stage. Now let us see each paper one by one. Thank you. Right, students, let us see the questions given in communication systems in this year paper. These are all memory based questions. So pretty good weightage came from this subject, but very few students have given questions which are given in this particular area. So what are the questions given at this present point of time? I am going to explain only them. Once we get the remaining questions, I will try to explain the remaining part also. Okay. So let us see these questions. See this first bit. Consider a real narrowband signal given by x of t equal to a of t into cos 2 pi fct plus theta of t. So here very clearly he is mentioning this as a product of two signals, where the maximum frequency components of a of t and theta of t are, I think this should be fm, this is a simple typo mistake, it might be fm, and fc. So here when you take the Fourier transform for this a of t, it looks like a baseband signal or a band limited signal whose maximum frequency is FM hertz, and this is definitely a carrier signal. So the carrier frequency is very high here. He very clearly gave that it is 1000 times FM. So here he is specifying that FC is very much greater than FM. Now observe carefully, you are multiplying a signal whose maximum frequency is FM with a carrier whose frequency is FC. So when you multiply, you will get a frequency in the interval from Fc minus Fm to Fc plus Fm on both sides. I am assuming that Fm is a baseband or a band limited signal. I am not taking it as a single tone signal. Okay. So this is a frequency range that you can expect here. Now what is he saying? Which of the following statements is are correct? So it's a multiple select question. So you have to be very careful while attempting these model of questions. So by seeing you can tell that it is looking like a DSBSC signal, and he clearly told a real narrowband signal. Narrowband signal means it's a band pass signal itself. Okay. Now see the options. X of t never represents a narrowband FM signal. So X of t is actually representing a narrowband FM signal. So you can leave that case. X of t represents a band limited Gaussian noise process. So here why it can become a band pass Ross? Because he did not tell anything on A of t. He told everything on the single tone signal only. So A of t can be a random process. We cannot expect that. So he is assuming that and giving that option. See the remaining options also, then we can come to a conclusion. See this C option. X of t represents an amplitude modulated signal for suitable choices of A of t and theta of t. So it can be an amplitude modulated signal because it's basically representing product of message with carrier. So it is like a DSB-SC signal. So DSB comes under amplitude schemes only. So this can be a correct choice. And X of t represents a band limited Gaussian noise process. It cannot be band limited, it can be a band pass, because even if you take A of t as a band limited noise, when you multiply carrier of very high frequency, it becomes a band pass noise. So it cannot become band limited noise. So there is a less chance that this can be correct, and you can also remove this. This is not X of t represents a narrowband FM signal. If it is an FM signal, then you should have a variation in frequency, but here he gave that FC is completely depending on FC here, FM here. So I don't think this can be also correct. So D option we could not get. Students could provide only these three options. So as per the data available up to here, we can confirm that C can be the right choice. Okay. So let us see. Once I get the data, I will update and you can go with the remaining case also. Let us see the next question. A wireless digital transmission scheme is using 16 QAM. So the modulation technique is very clear. It is 16 QAM. So that means M is 16 and you know that N is 4. That means you are doing a combination of 4 bits at a time and transmitting using one carrier. Modulation is of course QM. So some bits are used for phase and some bits are used for amplitude. Right. Now see the remaining part. And these are transmitted on an additive white Gaussian channel. So the channel is used is AWGN, standard point. And maximum likelihood receiver. So he is using ML. So what is the point that you have to observe here? When you use ML decoding scheme, the probability of bit 1 or probability of bit 0, both are equal. Means your receiver is observing S1 and S2 with equal probability. That is the meaning here. Consider information bit rate from source to be, so RB is given 4 into 10 power 6 bits per second. The minimum transmission bandwidth, so be very careful with that word. He is using a minimum transmission bandwidth. Minimum transmission bandwidth means what is the meaning? The type of pulses that he is using here is Nyquist sampling pulses. Or it can be sync pulses. Both are same. Then only the intersymbol interference will become 0 and the bandwidth requirements will become minimized. That is a condition. So what is the formula that we use here? It would be RB by log m to the base 2. This is a requirement on bandwidth. And this bandwidth itself will get automatically minimized. So that is what he is asking. The minimum transmission bandwidth in megahertz of the modulated signal necessary for optimum recovery of information. Optimum recovery means he is using an optimum receiver here. That means the threshold voltage is optimized. So what is this value here? It will be 4 into 10 power 6 divided by log 16 to the base 2. So the denominator would become 4, you will get 1 megahertz. That will be the answer. I think it's a fill in the blank question. So might be they have asked in megahertz. So your answer here should be 1. So it's a straightforward question, direct formula based question. No ambiguity in this question. Let us see one more question. See this one. This is also from digital communication only. A QPSK modulated signal. So QPSK means 4 PSK, quadrature phase shift keying. From an additive white Gaussian noise channel, so it is transmitted on AWGN and it is received with EB by N0, average bit energy to N0, power spectral density of additive white Gaussian noise is 8.4 dB. 8.4 dB means how much? 10 to the power of 0.84. Okay. Now what is he asking? He is saying that the receiver used is a coherent receiver. So you know coherent receiver or synchronous detectors, both are same. A maximum likelihood receiver, again ML detector. That means P of S1 and P of S2 are same. Assume the complementary error function, which is ERFC of U, which is BR at the output of demodulator. Options a student cannot provide us. So basically the question is on identifying the probability of error. And the two he is asking in terms of complementary error function. So we have discussed in class very clearly. Once you have this QPSK modulation scheme, normally for binary PSK I have told you, and then we will go with higher order PSK scheme starting with 8. But QPSK I have told as a special case where we will consider the initial phase as 45 degrees. Then the D minimum that you get in this QPSK scheme will be same as the value of D minimum you get in binary PSK scheme. So you will have 4 points here. The phase difference between any of these points would be 90 degrees, because 2 pi by 1 8 that 4 would become 90 degrees. So we are starting with an initial phase which is equal to 45 degrees. That is the point that you have to catch here. So this is your orthonormal basis functions phi of t and phi cap of t. That is the most important point. If you get that point, then you can solve this question. So what happens here, the value of d minimum which you are getting in QPSK with initial phase of 45 degrees will be same as the value of d minimum which you are getting in case of binary PSK, which would be equal to 2 into root EB. That's it. So what is the probability of error we have? We are writing it as Q of root over ED divided by 2 into N naught. For all synchronous detectors operating with optimum threshold voltage, this is the minimum probability of error. Now what is the value of ED? It should be d square minimum. So it should be equal to 4 into EB, because we got 2 root EB. When you square it, it becomes 4 into EB. So what would be this value? This is a Q of root over, substitute 4 into EB by 2 into N naught, you will get a 2 into EB by N naught. Now the question is not over here. He asked you to express in terms of complementary error functions. So half into ERFC of x by root 2 is Q of x. I told these points also. Whenever questions are given in ISRO like exams, they are using the complementary error functions. In GATE they will use Q functions. But here particularly he asked in terms of complementary error functions. So what would be this value? This would be half ERFC of EB by N naught. Now you have the value of EB by N naught, substitute here. He gave some mathematical appropriation that is not given in the question here. So some mathematical approximation for this exponential function in terms of this complementary error function is given. So you have to substitute there and see what is the value that you are getting. So it's a very good question. Definitely it will be a 2 marks bit only. So you can easily attempt this question. So these are the questions in communications as of now we got. Some more questions are there, but we couldn't find the data. Once that are there, then definitely we will update you. Okay. And once we get the total question paper, then you can easily go through our website and see what are the questions given in that area. Okay. Is it clear? Fine. So I will hand over the next subject. Next subject will be control systems taken by our JNR sir. He will give you the remaining questions. Thank you.
So in control systems, they ask for 8 marks. So all are direct questions, very easy. So first one from the RH criteria. Asked, they given a block diagram. K by S into S plus 7 into S plus 11 given. Unity feedback given. Asked to find K marginal. Simple third order system. K value for marginal stability they asked. Write the characteristic equation. So 1 plus G of S equal to 0. So what is the characteristic equation? S cube plus, add it, 11 plus, this is 1. So 11 plus 7, 18. This is 1, okay. 18 S square plus 77 S plus K equal to 0. Internal product, external product. So K marginal equal to 18 into 77. So you solve this, you will get it 1386 is the answer. Second question. This is block diagrams. This is solved in the class itself. So R of S. This is even previous gate and ESC question. So they given here 1 by S plus 4, C of S given, here summing point given, here positive, here given 1 by S plus 4, here negative, then negative feedback given. If you consider here error signal E, here the output is E by S plus 1, S plus 4. Here also you will get E by S plus 4. Positive and negative become 0. 0 means no feedback. No feedback means the equivalent block diagram is simply 1 by S plus 4. So the transfer function becomes what? 1 by S plus 4 is the answer. The next one is, so they given G of S. This is related to time domain analysis or general question you can say. So G of S given, total G of S into C of S. If you see the question, G of S, H of S, C of S is given as K into S plus alpha divided by S plus 1 into S plus 2. And they are asking find K and alpha value. Find K and alpha value so that the pole's location becomes -3 plus or minus j root 5. So for given data, write the characteristic equation, and to the given system write the characteristic equation, compare, you will get the answer. So if you write the characteristic equation for given data, S plus 3 whole square plus root 5 whole square equal to 0. So characteristic equation is S square plus 6S plus, so 14, 5 plus 9 equal to 0. So write characteristic equation for given data, S square plus 3S plus 2 plus Ks plus K alpha. So write here characteristic equation 1 plus this given function. So the characteristic equation become S square plus Sk plus 3 plus 2 plus K alpha equal to 0. So just compare it, you will get the answer. You compare. So K plus 3 equal to 6, K equal to 3. Next, K 2 plus K alpha equal to 14, K alpha equal to 12. So alpha equal to 12 by 3 means 4.
This is one question they asked. The next one is state space analysis. They asked the transfer function. The given data is x dot equal to state model given -4 -1.5 4 0 and x plus 2 0 here u and y equal to the given 1.5 0.625 x given. They are asking find a transfer function. They are asking find transfer function. What is the formula for transfer function? Y of s by u of s equal to c into si minus a inverse b plus d. Here D matrix not given 0. That means C into adjoint of Si minus A divided by det of Si minus A into B. So if I write Si minus A, what is Si minus A? Si minus A. Simply add S diagonally, take opposite sign. So this will become 1.5. This is -4. This will become S. So this is S. This is Si minus A. So find the transfer function. C. C is 1.5 0.625 into adjoint. Adjoint means S. S plus 4 minus 1.5 here 4 into B here 20 sorry this is 20, so that means here 20 divided by det what you are getting, s square plus 4s plus 6 is the det. Then you product it numerator, you will get 3s plus 5 divided by s square plus 4s plus 6. The next question is, so they given, this is also related to state model only. They given w dot equal to a into w, that means it is a homogeneous state equation given. Homogeneous state equation given here, and is given w naught initial. So that given 1 1 initial matrix, they given 1 1, and solution to the state model given. The solution to the state model is wt equal to e power t into ux plus e power minus 2t into uy. This is the final solution given, and given 4 options. He is asking matrix A, find state matrix. Find state matrix A, they are asking. Find state matrix A. The given options is 1 0 0 minus 2. B option is given 0 2 minus 1 0. C option is given 0 minus 2 1 0, and D option is given -1 0 0 2. You observe the options they given here, diagonal matrix they given. Simply diagonal matrix, so it is nothing but a pole locations. Simply diagonal matrix is nothing but a what? Pole location. What are the pole location from the output you tell? Here one pole location is what here? 1. This e power at, that means here pole location 1, here pole location 2. So diagonally it should be 1 and -2. So that means option A is correct. That's all total. 8 marks, 2 questions from the state space it came. All are direct questions only. Next, maths sir will continue.
Good afternoon, everyone. In maths, we have around 10 marks given, but as of now, we have received only one question. So first, let me cover that. Later on, if new questions have been arrived, we'll include them as well. So we were given a matrix m equal to 2, 1, 1, 1, 3, 0, minus 1 AB. Which of the following statement is true, or which of the following statements are true when det m not equal to 0? So that means one or more options correct, it is MSQ. So let us calculate the determinant of the matrix. Det m equal to 2 into 3b minus b plus a plus 3 equal to 0. Sorry, not equal to 0. So this is 6b minus b, that is 5b plus a plus 3 not equal to 0. Now we have to verify the options for what values of a and b, this value not equal to 0. So a value 1 by 2, b value 1 by 2. If I take a value 1 by 2, b value 1 by 2, 5 by 2 plus 1 by 2, 6 by 2, 3 plus 3 not equal to 0. So for option A, determinant not equal to 0, therefore option A is correct. Now verify option B, a equal to minus 1 by 2, b equal to minus 1 by 2. If I take a equal to minus 1 by 2, b equal to minus 1 by 2, this is minus a equal to minus 1 by 2 and b equal to minus 1 by 2, this is minus 3 plus 3 0, but their determinant not equal to 0, therefore option B wrong. Here a 3, a minus 3, b 0. If I take a equal b 0, it is 0, a minus 3, b 0, then answer minus 3 plus 3 0. So for the values given in option C, determinant is 0, but the condition is for what values of a and b det not equal to 0. Accordingly option C eliminated. Now a equal to 1 by 2, b equal to minus 3, b equal to minus 3. So therefore it is minus 15 by 2, a equal to 1 by 2, that is minus 14 by 2, minus 14 by 2, minus 7 plus 3, minus 4 not equal to 0. Therefore option D also satisfying the determinant not equal to 0, and hence options A and D are correct. So that's it as of now. We'll update soon. Next signals Narasimha sir will continue.
So let us see signals questions. I got the data just now. X of t is given by this expression. He is asking for energy ratio. Once you draw the signal graph, it is a simple rectangle from 0 to 1 having amplitude 2. What is the standard formula for rectangular pulse of width t? A square t is our logic. So what is the energy you can say in the signal? 2 whole square into 1. If you feel signal energy is like E, if you feel signal energy is like E, what is A times xt energy? A square times original. Suppose you want to scale it. It is like A square E by mod alpha. Alpha can be negative, but energy cannot be negative. So what is expected? Energy in x of t. How much we got? 4. Here x of minus 3t plus 5. For that, what is the energy you can take? E by mod alpha extra A square. 3 whole square 4 by 3. That is 4 by 12.33. So this is what the information given by students. Okay. Let us see the next question. This is a funny question. Continuous time signal xt is real and periodic. The standard exponential Fourier series form is given. He is saying, what is this condition? Half wave symmetry. Half wave symmetry strictly contains which components? Odd harmonic components. Odd harmonic components. Indirectly even harmonics, the coefficient is 0. When there is a possibility of even harmonic, when m is multiple of 2, a to m, this corresponds to even harmonic. As it obeys half wave symmetry, even harmonics coefficient amplitude is 0. What is the next model? This is a funny question, copied so many times in ESC, even in gate paper, of course. Today also it happened. Some difference equation is given. Yn equals to 5 by 6 y of n minus 1 minus 1 by 6 y of n minus 2 plus xn. Of course, the input is also given. He is asking the nature about the output. Input is given like del n minus 1 by 3 del of n minus 1. So what is the jet transform for this? When you take jet transform, 1 minus 1 by 3 jet inverse. Here you try to solve for the transfer function by taking jet transform. So the transfer function is yz by xz. When you do simplification, so it is going to produce this result 1 by 1 minus 5 by 6 z inverse plus 1 by 6 z power. So the denominator can be written as 1 minus 1 by 3 z inverse into 1 minus half z inverse. Those are the roots. Once you take product, so when you multiply this xz as well as hz, what you are left with in the output? 1 minus 1 by 3 z inverse cancellation. You are left with what? 1 by 1 minus half z inverse. So yz is 1 by 1 minus half z inverse. So the inverse z transform is 1 by 2 whole power n un. What is asked in the question? Nature of output. Causal, non-causal, stable or unstable. So it covers only positive index. Means it is a causal function. Of course it is stable. Output is maintaining finite amplitude level. Causal and stable. This is a standard question from our material which we use it to solve in the class. Some signal x of t is given. Find the essential bandwidth B such that it contains 99% of original signal energy. So let us assume energy within bandwidth B as EB. Let us assume like that. So that fellow is saying it is 99% of signal energy. 99% means 0.99 times of original. So let us calculate energy in the signal first from time domain 0 to infinity, because it is a positive side function, square of the signal, result becomes 1 by 4. Try to take its spectrum, Fourier transform 1 by a plus j omega 2 plus, apply theorem for the given signal, Parseval's theorem. So how to calculate 1 over 2 pi integral of mod x omega whole square d omega. So EB you can treat as 1 over 2 pi integral minus b to b, integral minus b to b, magnitude of that term 1 by 2 plus j omega whole square d omega. Anyway, this is even symmetric, so I can write that as 2 times. So further it is 2 by 2 pi integral 0 to b. What is that? Simplified quantity. Because it is even symmetric, minus b to b became 2 times 0 to 1 by omega square plus 4. Okay. So that is 1 by pi standard integral 1 by 2 tan inverse omega by over the limit 0 to. So 1 by 2 pi tan inverse of b by, what is stated in the question? EB is 0.99 times energy, means 1 over 2 pi tan inverse of b by 2 is 0.99 times, what is that number we got? Energy in the original 1 by 4 original. So tan inverse b by 2 is 0.99 into 2 pi by, so do that further enjoyment, take tan of that quantity, I think we are getting 127. So whether it is given as a numerical type or whether it is asked in Hedge scale, that we don't know, but this is the procedure. This is the procedure for that question. Okay. We have a few more questions that will be handled by the next faculty member, Mr. Srikanth.
Okay, the next question in signals and systems is x1 of t is cos 2 pi nt and x2 of t is 2 sin 4 pi nt. Represent two sinusoids for a positive integer n and t ranging from minus infinity to plus infinity. Which of the following statements are correct about x1 of t and x2 of t? Once you see the first option, x1 of t and x2 of t are orthogonal to each other over the interval 0 to 1 by n. What is the condition for orthogonality? They are the periodic signals. So integration x1 of t into x2 of t into dt is equals to 0. They are the periodic signals, so over one period. So if you take the common period of both the signals, what is the common period? You are going to get 1 by n. So integration 0 to 1 by n, this integral value is equals to 0. So we can say that those signals are orthogonal to each other. So first statement is correct. See the second statement, x1 of t and x2 of t are non-orthogonal over the interval 0 to 1 by 2n. No, even if you take 1 by 2n also, this value is going to be 0. So they are orthogonal over that interval also. So the given statement is false. B statement is false. They are orthogonal, but given that non-orthogonal. So B statement is false. See the C1, x2 of t is a harmonic of x1 of t, correct. It is a second harmonic of x1 of t. Once you see here, 2 pi n and 4 pi n. See the last option, x1 of t and x2 of t are orthonormal to each other over the interval 0 to 1 by n. What is the condition for orthonormality? They have to satisfy two conditions. First condition is orthogonal to each other. Second one, they should maintain unit energy. They are satisfying the first condition. They are orthogonal over this interval. But if you find the energy, integration x1 of t into x1 star of t dt over the interval 0 to 1 by n, this value we are not going to get 1. Similarly, x2 of t into x2 star of t into dt value is also we are not going to get 1. So these are not satisfying the unit energy condition. So these signals are not orthonormal. So D option is also false. So what are the right option? A option is correct, C option is correct. It is a MSQ question. And the last question from signals and systems, it is from Laplace transform. It's a simple one. The signal given as u of t minus 2 convolved with t into u of t. What is the Laplace transform of this one? See, u of, it is a convolution. If I apply Laplace transform, convolution converted to multiplication. So what is the Laplace transform of the given signal is, what is the Laplace transform of u of t minus 2 from the time shifting property? It is e power minus 2s divided by s multiplied with, what is the Laplace transform of t into u of t? It is a ramp signal. So the Laplace transform is 1 by s square. So finally e power minus 2s divided by s cube. So what is the right option? E power minus 2s by s cube. So the right option is A. So these are the questions till now we have received from the students from signals and system subject. And the next subject is EDC by Trinath sir.
So hi dear students, welcome back. Now let us go through the questions what we have received from the students in the subject of electronic devices. I understand most of these questions what we received from our students we discussed in the class itself, right? That's a good thing, dears. And around 9 marks till now what we have received from the input. And if you check it out, you know, the very first question, have a look carefully guys. Consider a PN junction diode when it is forward biased with a 2 volt, right? Biased, we disturb the equilibrium. Diode is under forward bias, 2 volt externally examiner has provided. Which of the following statements must be true? So, you know, right. So he is asking about a quasi levels. Guys, I hope you remembered since 1987 to 2025, if you check it out, not even a single question we got from the quasi levels, right? This is the first time, and I predicted this in the classroom, and I clearly discussed that no PYQs we have in the quasi levels. Let us go a detailed discussion about quasi levels as I discussed in the class, and the quasi equilibrium levels I discussed in the class. True or not, dear students, right? And right, the same thing, we got it. That's a very good news what I understand. Now if you check it out, students, if I go with a, you know, forward bias, right? So take it as N type and P type, right? N type, if I contains the positive ions, the depletion region, and P type, negative ions what we have. As we say, forward bias indicates, respond here students, it will be in this way, right? So the, you know, the force, this is a junction force acting on electrons. So this is the way how we are going to get the energy band diagram, right dear students? The energy band diagram under forward bias, equilibrium got disturbed. So if I check it out here, N-type semiconductor, Fermi level, yes, near to the conduction band, it is near to the valence band. As it is a quasi-equilibrium, it must be shifted, and it must be in this way, that is because of the diffusion, there exists a slope, the quasi levels. In the similar way, this is the graph with respect to the energy and the distance. Y-axis must be energy and x-axis must be distance, true or not, the quasi levels, right? And this is nothing but the quasi-equilibrium Fermi level for n-type and the quasi-equilibrium Fermi level for p-type. You remembered or not, dear students? So what is this height of this lobe? EC, EV. What is this height of this lobe? Is nothing but Q times junction voltage. True or not? Similarly, what is this height of this lobe? This height of this lobe is nothing but what here? Q times diode voltage. That means the difference in the Fermi levels must be Q times diode voltage. So Fn minus Fp, if I say it is a Q times diode voltage, then diode voltage, what examiner has given is 2. Therefore, 2 electron volt must be the right answer for the given question. So I understand if this data is correct, what our students given to us, then 2 electron volt must be the right answer for the given question, because examiner clearly asking about the difference between quasi Fermi levels. That means examiner is expecting answer in terms of energy. If it is energy, it must be 2 electron volt. If it is voltage, it must be 2 volt. Take care of that. Right, yes? Go through the next question. You can check it out. This is under the breakdown mechanism, right? So consider the carrier transport in a Zener diode in the breakdown region, right? So you know that less than 6 volt. The Zener diode breakdown will be Zener breakdown, where it will work under tunneling principle. The carrier transport mechanism must be what here? Tunneling principle. Whereas greater than 6 volt to around the 3000 volt avalanche breakdown, that is a ion implantation mechanism. Ion implantation. I mean to say like a impact collision, I could say it is impact collision. True or not, dear students? Collision effect or impact collision effect or a thermal collision effect. Whereas if you check it out, it is clearly specified the breakdown in the breakdown region, the breakdown mechanism, dominant transport mechanism is what examiner is asking. So ballistic transport, no, that is not right. So tunneling, yes, for Zener breakdown, tunneling is the carrier transport what we are supposed to consider. It is not impact collision, examiner has given in the option. Drift and diffusion, no, we need not to take, and I'm supposed to go with only tunneling, right? So option B is apt for the given question, right? If you check it out, the next question, dear students. So nice, this is for optoelectronic devices. So consider a light emitting diode based on the direct band gap. Yes, it is for sure. Whenever you're going for laser diodes or a light emitting diodes, you're supposed to go with only direct band gap semiconductors. True or not? That's why we don't go with the silicon and germanium, which falls under indirect band gap semiconductors. Now, right. So energy band gap. So energy gap, examiner has given as 1.3 electron volt. Now, given the Planck's constant h, okay, fine, and the speed of the light in the free space he has given, fine. Then in which of the following wavelength ranges the LED will not emit light? Very easy question. Seriously, very easy question, right? You know that, students, lambda max, the maximum wavelength, I could say the lambda max will be how much, dear students? See, this is E is equals to 1.24 by lambda micrometers in electron volt. True or not? Then lambda max must be how much, dear students? It must be, if I go with micrometers, but examiner, okay, in the options, I hope he has given in the order of nanometers. So whenever it is in nanometers, you can convert into nanometers this one. I think it must be 12,400, right? Whole divided by, it must be nanometers. And, energy gap, examiner has given as 1.3 electron volt. So this must be lambda max. So if we could solve, dear students, I understand the lambda max what we got is around 953.8 nanometers. This is what we got. Now what exactly examiner is asking, in which of the following wavelength ranges the light emitting diode will not emit? So what it shows, the highest wavelength where it can emit light is nothing but 953.8 nanometers. Above that, any wavelength what you are expecting from light emitting diode is not possible for this specific energy gap given data. That means greater than this, that must be the answer what you are supposed to choose, because he is not asking which wavelength range will emit light. He is asking which doesn't emit light. Then I think, so below this is accepted, that means 953.8. I think this is representing this wavelength, representing a light, LED will emit light, and 510 plus 20, yes, representing LED will emit light, but he is asking LED will not emit light. Then I hope option A and option B is apt for the given question. If this data is correct, I think that must be MSU question, multiple select question. Right, dear students? And one more question I have received from our students. Consider the electron concentration of consider the concentration of electrons in a semiconductor bar varies linearly from, right? So there exists concentration gradient. Concentration gradient exists indicates, I hope you know that. We can go forward here, diffusion. Diffusion will give you built-in electric field. That built-in electric field will give you carrier transport equation. So at equilibrium, total current must be equal to 0. So let us decode the equation carefully. So it is varying linearly. So let me say electron density. So y-axis, it is n of x. X-axis, I say distance. Now, what is the first case, dear students? Linearly varying from 2 into 10 power 17, the highest value, 2 into 10 power 17 per centimeter cube, right? And this is at a distance of 1 micrometers. So this is 1 micrometers. So it is in centimeters, not here. So convert into centimeters, 10 power minus 4 centimeters, I hope. Right, dear students? Now, next. And 1 into 10 power 16 centimeters. That is this one. 1 into 10 power 16 per centimeter cube. So right, it is 4 micrometers. Then it must be, right, 4 into 10 power minus 4 centimeters. So, at this point, this is the data, and for this must be the case. Then I understand this is the gradient what examiner has given, the slope. That means the concentration gradient is there. Okay, fine. Now, right, then mobility is provided by the examiner. Mobility is how much, guys? 1400. So mobility of electrons examiner has given. So 1400 centimeter square per volt second. Guys, thing is, everything is in centimeters. You need not to change units, right? Mobility is given. Thermal voltage. So thermal voltage, it is 28 millivolt. I don't know whether this is right data or not. Commonly we go with at 25.9 or 26 millivolt if it is at room temperature. But he has given 28 millivolt indicates, if I'm not wrong, it is not under the room temperature condition is what taken by the examiner, right? Now what he is asking, the charge of electron he has given, then density of electron diffusion current, I think it's a printing, there is, I think data is something missing here. If I'm not wrong, we are supposed to find the electron current density, I hope. Diffusion current density, right? Density of electron diffusion current density. Okay, fine. Electron diffusion current density. Then in that case, Jn diffusion. Students, the similar numerical I explained in the class, have you remembered or not? There is a situation where concentration gradient maintained constant. This was one of the previous questions, and I related this to the bipolar junction transistors in the forward bias. Correct or not, dear students, right? But here it is very easily given by the examiner that you need to find only diffusion current, not even a trick he has given, right? So lucky, I think. So this time I could understand the paper is easy in my subject. Okay, but anyways, Jn diffusion, if I check it out, it is like a q dn of x by dx. Q dn of x by dx. This dn you can represent like this, mu n into thermal voltage. Mu n into thermal voltage. Mobility given by the examiner, thermal voltage given by the examiner, q, you know that, and dn by dx you can measure from here, right, dear students? So that is what, dear students? So it is 1.6 into 10 power minus 19 coulombs into, what is mobility, dear students? 1400. So 1400 centimeter square per volt second into 28 millivolt, that means 28 into 10 power minus 3 into the slope. Respond here, 2 into 10 power 17. So it is 2 into 10 power 17 minus 1 into 10 power 16 whole divided by, right, minus 4 into 10 power minus 4, minus 4 into 10 power minus 4. I think no need to change units, everything is done under amperes per centimeter square. That is what we are going to get. If I could solve, what we got is minus 3.9 milliamps per centimeter square. Minus 3.9 milliamps per centimeter square. I hope it must be the numerical answer type NAT question. So answer is minus 3.9 milliamps per centimeter square. Still one or two questions might be there, dear students. That is what we are getting, but we did not get the data as it is a memory based. I hope you have done well in these questions. So as per the data what we got till now, it is like a 9 marks. It might be changing. Once we get a clear data, you will be getting information very soon for sure from our team. Right, dear students? Thank you so much. Hello friends, good afternoon. Under networks, 3 1-mark questions came and 2 2-mark questions came. Till now we have the clarity regarding the 4 questions. I would like to discuss those 4 questions. Let us take the first question. The question is, consider the circuit shown in the figure where the input Vi of t is in volts. The average power in milliwatts dissipated in the load resistance of 1 kilo ohm at the resonant frequency is. It is given that a standard RLC parallel circuit here. You know that for RLC parallel circuit, under resonance circuit nature is resistive. That's why the average power dissipated by the resistor directly you can take it. The formula as P average is equal to Vrms whole square by R. Very simple. This is very simple here. 1 more question. Vrms means here it is given as a here 12 sine omega t. That's why 12 is the maximum value. RMS value 12 by root 2 whole square by 1k. And we are getting that 144 by 2k, you will get it. From that 72 milliwatts you will get it. But he asked that this question is under NAT, numerical analytical type. That's why you take the answer as a 72. You need to type it that keyboard as a 72. Answer is 72. Let us take the next question. Right. The output voltage V0 in volts for the given circuit as shown in the figure. I will draw the figure. It is under basic terminology that question is given. The circuit is, it is also very simple circuit here. Once you see the circuit, you may get so many simplification techniques out of that. I would like to take that simple nodal analysis, but so many students, I got the information regarding that they are using the superposition theorem like that. You can also use the superposition theorem to obtain the V0 value, but I would like to take that simple nodal analysis. This is 6 volts. Since it is a DC, this is 1k and 1k and 1k. All our resistances are same. I want V0. Now for this, I would like to consider that this node voltage as a V1 and this node voltage as a V2. Then V1 minus V2 is the V0. V0 value is equal to V1 minus V2 value. Now we need to focus how you have to obtain the V1 and V2 values. To get that by KCL at V1 and V2, you will get it. By KCL at V1 means V1 minus 6 by, since this voltage is the 6 volts with respect to ground, this one, and by 1k plus V1 by 1k, and incoming current is this is incoming current. That's why here these currents are outgoing current. That's why 1 milli. And with this 2 V1 minus 6 is equal to 1. From this V1 value you will get it a 7 by 2, 3.5 volts. Similarly, you will consider that this is at V1. I would like to consider that same KCL at V2. Same equation you will get it, V1 V2 minus 6 by 1k and V2 by 1k, and this one is also outgoing. That's why plus 1 milli is equal to 0. Now from this, if you simplify, you will get V2 value is equal to 2.5 volts here. Now our required value is equal to V0 as per the given question, and we have to be considered that V0 is equal to V1 minus V2, that is 3.5 minus 2.5, which is equal to 1 volt. You are getting that. I think this is given under MCQ, NAT, numerical analytical type. That's why in volts we need to type with that virtual key as a 1 volt or 1. So let us take that next example. Right. This is the good example here under AC circuit analysis. In the given circuit, L is equal to 1 microhenry and C is equal to 1 microfarad. The phasor diagram for IC and IL is also shown in the figure. Assume that the phase theta 1 plus theta 2 is 90 degrees at a frequency of 159.15 kilohertz. Among the following options, what is the nearest integer value of the product of RL and RC? Let me take the diagram. Once I draw the diagram, definitely you will realize that
this is the standard circuit. Once you recall under AC circuit analysis, guys, you will get the standard circuit under parallel resonance. This is the type 3. This is RL and RC, L and C. And here the phasor diagram also given. The phasor diagram, this is the applied voltage and this is the capacitor branch current and this is the inductor branch current, and it was given this as a theta 1 and this as a theta 2. Guys, if you observe that whatever the condition was given here, theta 1 plus theta 2 is equal to 90. Nothing but the inductor current and the capacitor currents are quadrature. Once both are displaced by each other is equal to 90 degrees, you have the direct relation for this one. Suppose if you consider this is IL and this is IC, and you have the direct relation under resonance, parallel resonance for this type 3 circuit. RL is equal to RC is equal to under root L by CR. Once you remember this, you will get the answer. Now, what is our required value? RC into RL, right? Let us take that RL into RC or RC into RL is equal to, if you multiply the same, you will get L by C. Whatever the values are given, L and C, both are 1 micro by 1 micro, you will get as a 1. Now, this is given under MCQ, option A is the correct one. It's very simple. With the 2 marks, once you know this relation, it is very simple here. Right. Let us take the next example. Right. This is under 2-port network parameters here. The question is, consider the 2-port network as shown in the figure. Which one of the following options provides the correct set of values A, B, C, D parameters? Now, the circuit is given. It is given as a T network, 2-port network given here, which contains all the resistance values are equal. This is 1K and this is 1K and this is 1K. Here guys, this is V1, input port voltage and input port current. This is the circuit given here. And if you want to extract that ABCD parameters, normally whenever a standard network, if this is the standard network, and once you see this network under 2-port network parameters, mainly we need to focus whether the network is reciprocal and symmetric. If you see this network is reciprocal as well as a symmetric. That's why here once you see that options, we'll come to that from the options to that answer. Here A is AD, A equal to D, and B is equal to A equal to D, it is not D, and C value A equal to D, and D is A is not D, A is equal to D is there. That's why we should go for the directly here according to that how you have to extract the ABCD parameters. If you want to do that, we can go for in 2 things by using the symmetric and reciprocity condition. And next one is, if you take this entire network under subnetworks with the cascade connection. Cascade connection means what? Once you divide the network into 3 parts with the subnetworks, this is the first network, the cascade, which is connected with the second network, cascade, which is connected with the third network in cascade. Because you know that for series element ABCD parameters 1Z01, for shunt element 101 by Z1, for series element 1Z01. If you do that, you will get easily, right? If you do that, you will get easily. Now, I would like to take in that only, directly I can get it, extract that. Since you are having the confusion regarding the given options, that's why a direct method you can take it. That is the cascade connection. If you do the total network T parameters is equal to T1 into T2 into T3. It's a very simple here, only mathematical calculations. You are not having any technical calculations, nothing but whatever the subject calculations. 1Z01, 101 by Z1 and 1Z01, right? Now, according to that, you will get it. Only matrix multiplication 1Z01. If you do that, you will get 2. This one is 1K, and this one is 1 by 1K, and this one is 1, and 1K 0 1. Guys, get that? simplification for this, directly you will get it here. This is 2, and what we are getting that 2k plus 1k, which is 3k, and this one is 1 by 1k, and this one is 2. You have to get it because A should be equal to D according to that what symmetric condition. Symmetric condition is equal to what for ABCD parameters? A equal to D, and this is also reciprocal since it is the passive network. AD minus BC should be is equal to 1. That also it has to satisfy. And once you see that, as per the obtained ABCD parameter values, if you take that, if you verify in the options, option A is the correct one. Option A is the correct one, right? Option A is the correct one. These are the questions which we got till now, right? We will see that rest of the questions, whatever the questions exactly. Okay, all the best, guys.
Okay, so let us look at analog circuits. Go through the question. An ideal op-amp circuit shown in figure produces a voltage V0 equal to X when switch is open. So X is, when switch is open, 1 plus 2 plus 1 is 3, 3k by 1k into 1, which is 4 volt. It is X. Now he wants you to relate with Y when the switch is closed. When the switch is closed, it is 1 plus 2k by 1k into 1, which is 3 volt. Now what is Y in terms of X? Y by X equal to 3 by 4, or Y is 3 by 4x. This is the solution. So option D is the right answer. Consider an ideal op-amp circuit shown in figure. If all resistors are of same value 50k, the magnitude of the closed loop gain, he is asking you the closed loop gain V0 by Vn. So let us take this unknown node as Vx and solve. This is virtually 0 because of negative feedback. So Vx is minus R by R, minus R, all resistors are of same value, into Vn, which is minus Vn. Now what is Vx in terms of V0? Let us apply KCL. Vx by R plus Vx by R plus Vx minus V0 by R is 0. So now you got the solution. V0 is 3Vx and Vx is minus Vn. So he is asking you to find the magnitude. So V0 by Vn is minus 3, which is 3. 3 is the right answer. Okay. Now the circuit uses an ideal op amp shown in figure. Which of the following gives the correct value of current? He is asking you to find the current value here. This node is virtually at 0. 2 by 1, 2 milliampere is flowing here. So this current should also be 2 milli. Now because of the polarity, we know this unknown node Vx is going to be 2 into 1, which is 2, minus 2 volt. So now let us find Ix and finish the problem. Ix is this current plus this current, summation 2 milli plus 0 minus 2 by 2k, 0 minus of minus 2 by 2k, which is 1 milli. 2 plus 1 is 3 milli. 3 milli is the solution. Now an N-channel MOSFET is connected as shown in figure. VTH is given as 1 volt, VDD is 5 volt, mu Cox is 1 milliampere per volt square. Now the gate voltage, this is 1 milliampere per volt square, the gate voltage Vg you have to find. Now assume the MOSFET is in saturation, this is 1 milli in the question. Assume the MOSFET is in saturation, K times of Vgs minus Vt whole square by 2. It is again a simple substitution problem. VDD is given as 5 volt, 5 minus Vg by 1k. K is 1 milli. Vgs is Vg minus 1 whole square by 2. So cross multiply, 10 minus 2 Vg is 1 milli and kilo, they get cancelled. This is A minus B whole square, A square plus B square minus 2AB. So now Vg is 10 minus 1 root 9, which is plus or minus 3. Now in this, which is the right answer? Between ground 0 and 5, it makes no physical sense that you have negative voltage. So this has to be 3 volt only. 3 volt is the right answer. Now 2 more questions are there. One is the diode problem. So this diode problem, he is asking you what is the maximum output voltage? What is the maximum output voltage? V0 max. So the values are 2 volt, 4 volt, 10k, 10k. Now let us solve this problem. Please see here. For maximum, let me take 6 volts here. Let us apply some common sense and finish the problem. What is 6 minus 2? What is 6 minus 2? 6 minus 2 is 4. 4 volt is dropped across the 2 resistors. 4. Because it is in series, 2 will be dropped here, 2 will be dropped here. So now 2 plus 2 is going to be 4. So that is the right answer. So let me repeat, when this is 6 and this is 2, the potential difference is 4 for the same series current. 2 plus 2 is 4. 4 is the right answer. And one more is there. An op amp drives a BJT. The input voltage here is given as 3 volts. Now you are asked to find the current driven by the op amp. The current driven by the op amp is the question. Okay, that is the base current. So now if this is 3, this node is at 3. 3 by 3 is 3 milliampere. Beta is given as 99. Okay, so what is this current? That is the solution. This current is going to be 3 by 1 plus beta, 100. It is 30 microamp. That is the solution. Okay, so that's all from analog circuits.
Yeah, hi students. There is some mismatch in this question. I did not gone through the option carefully. Actually, we did not get the options before, dear students. Now we got a clarity about the options. You could check it out. Examiner is exactly asking, in which of the following wavelength ranges the LED will not emit light. So what we got exactly the lambda previously? What are the previous lambda we got, dear students? Lambda value we got, which is so called lambda max. Am I right? How much we got exactly? It is a 953.8 nanometers. True or not? So any lambda greater than 953.8 doesn't emit wavelength, doesn't emit light. So here it is, I thought it is 930, so it is 950, it is not 930. So 950 plus or minus 920, so 950 plus 20, it is very clear 970, which is greater than that. So damn sure even this is right, and this is right, this is right. So for this given question, option A, option B and option D must be right. Is it okay, dear students?
Hello friends. So from the general aptitude, we are getting two questions from the student based on the logarithm. Log y p power 1 by n into log p y power 1 by n, okay, is equal to 16. What is n? What is n? So already know, my dear friends, here 1 by n, bring the front side, so it becoming n. N log y base p. Here also n into log p base y. So n square log y base p. This value 1 upon log y base p, both cancel, is equal to 16. So n square 16, I want n value. So 4. One of the question from the logarithm. And next one, find the value of P1, P2, P3, like up to P10. Here what is the P? P means perimeter. Perimeter of square. Perimeter of the square. Okay. And they given P suffix K. So K is called length. K is called length. Okay. So these 10 numbers, simply 10 numbers. So 4 into 1 perimeter. 4 into 1 like up to 10 numbers. Okay, up to 10 numbers. 4 perimeter. So that's why 4 into n into n plus 1. 10 into 10 plus 1 upon 2. So 2 5s. 20 into 11. So 220 is the answer. These two questions from the memory based, okay, and general aptitude remaining questions very lengthy. For memory based also time taken. Okay, so these two only we are getting as soon as possible. Okay, after getting the official question paper, we are giving the complete clarity to you friends. Thank you.
Right, let us see questions from digital circuits. There was a question on Boolean algebra. Consider the 4-variable Boolean function f of x, w, x, y, z is equal to sigma m of 0 to 5, 7, 8, 10, 13, 14, 15, with w is MSB, z is LSB. Which of the following expression is oblique are the valid forms of f of w, x, y, z? See, we need to find right, which one is equivalent to this. So that is very easy, which we discussed in the class. We need to go with the verification with min terms. So when it is given that function and it is equivalent to or it is represented by such type of questions we have seen. So simply writing min terms of options, it can give correct answers. See, if you write min terms of A, B, C, D, A and D are matching with the given function. So in this, obviously 7 will be missing. Here 0 will be missing. So option A and D are correct for this. There was one more question from number system. What is the tens complement of 4, 7 decimal? So 4, 7 decimal, we need to find tens complement. You can use either 9's complement plus 1 or you can use direct method. So if you observe that 4, 7, first non-zero LSD should be subtracted from R, which is 10, 10 minus 7, which is 3, and remaining digit should be subtracted from R minus 1, which is 9, 9 minus 4, it is 5. So answer is 5, 3, option D. Let us see next question. So very simple question was given from counters. So a binary ripple counter is designed to count 0 to 64. 0 decimal to 64 decimal, it has to be right designed. So total number of states are becoming 65. So to design a counter with 65 states, so we need to, if it is 6 to power 6 is 64 only, but when we have 65 states, it is you need to use it is 7 flip-flops. With 6 flip-flops maximum we can generate 64 states, 0 to 63, but here it is 0 to 64 means total number of states is becoming 65. For designing such counters we need minimum 7 flip-flops. A direct question was given from CMOS, a simple question. In the circuit shown in the figure, A and B are logic inputs and Y is the logic output. So what function it is representing? Obviously these two are in parallel, these two are in series, so it is going to be a 2-input NOR gate. Options are not visible here, so it is option A, it is 2-input NOR gate. There was a question from multiplexer, very simple question. Circuit is missing here. Let me write the circuit. Here S1, S0 are connected to X and Z. Here 0, 1, 2, 3. So this 0 is connected to 1, 1 is connected to 0, 2 is connected to 1, 3 is connected to Y. It is a 4:1 mux. You need to find f of X, Y, Z expression. So simply we can write S1, S0 in our method. So S1, S0 are connected to X, Z, 0, 0, 0, 1, 1, 0, 1, 1. So here we say that I0, I1, I2, I3. And here it is Y can be 0, Y bar, and Y can be 1, it is Y. So what we can write combination numbers here, X, Y, Z 0, and here it is 2. Here it is 0, 0, 1, it is 1, it is 0, 1, 1, it is 3, then 1, 0, 0 is 4, and 1, 1, 0 is 6, then 1, 0, 1 is 5, 1, 1, 1 is 7. So if you are observing I0 is 1 means these two are minterms, I1 is 0 means no minterms are there, I2 is 1 means again these two are minterms, I3 is Y means this is one minterm. So what we have here, it is sigma m of 0 to 4, 6, 7. If I use a 3-variable K map, X, Y, Z 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So 0, 2, 4, 6, 7. So it is one grouping and this is second grouping. The first grouping is giving that Z bar, second grouping is giving that X, Y, X, Y. So X, Y plus Z bar, option is D. Now let us see one more question. the address of first location of a 256 kilobyte memory is 2500 hexa. Choose the correct address of the last location of the memory. So if you observe that 2500 hexa is starting address and here it is 256 kilobytes. So each location we can consider as 1 byte, then it is 2 power 8 into 2 power 10. So it is 2 power 18 locations you need to count. So what is starting address? 0010 and 0101 and 000. So for this we need to add 18 ones to get ending address. Let me add this 18 ones because 2 power 18 locations 16 again 2. So let me add here, it is 1 1 1 1 again 1 1 1 1. Here it is 0 0 1 0 0 1 at 0 0 0 0 1. So let me convert to hexa. It is F, it is 4, it is 2 and it is again we can say 0. So 4 2 4 F hexa, 4 2 4 F hexa. So option D. So you can consider it is from CO. The question is from CO. Let us see next question. Right, some questions are missing. Let me give you. Right, there was a question, a JK flip-flop, a negative edge triggered JK flip-flop, and J and K are tied to 1, and it is applied a clock with 10 cycles per second. Then what will be the output frequency of this? So as we know that it is a divide by 2 because it is a JK11 is saying that at every clock edge occurrence it is complementing. Obviously we know that when you say it is the clock, if you write flip-flop output, obviously it is going to be like this. At every negative edge it is complementing. So obviously if it is a clock period is T, it is going to be 2T, then frequency is divided by 2. Obviously option right answer is 5 cycles per second. So frequency of output it is 5 cycles per second. And one more question was given in registers. Let us see one more question. So it is given an 8-bit register like B7, B6, B5, B4, B3, B2, B1, B0, and here it was a D flip-flop, D, Q, Q bar, and this Q is input of XOR gate. Another input of XOR gate is connected to 1, and it is like this. So this clock and clock for this register is also synchronous. So initially all were reset. After 5 clock cycles, what is going to be the status of register? So it is initial is so if it is all zeros, what we can say here, it is right, it is all zeros and input of XOR gate is delayed by 1 clock cycle, and here it is a D flip-flop, D, Q, Q bar, and XOR gate, that is here. So obviously after first clock cycle the contents is going to be what? 0 0 0, right? It is going to be 1 here, right? So 0 0 0 1, it is the register content after a clock cycle. So after one more clock cycle, what do you observe here? So again 0 will be the input of XOR gate, another input is 1. So when 0 1 is there, obviously again 1 will be there, shifting left 1 0 0 0 0 0. That is after second clock. After third clock cycle again it is going to be 1 should be applied because 0 and XORing with 1 is going to be 1 again. So it is 3, right? It is third clock cycle. After fourth clock cycle, again what we can say here, 0 is again applied here, 1 is XORed with 0, and again 1 will be applied in the rightmost. So it is going to be 1 1 1. So 0 0 0. It is the register content after 4th clock cycle. If I say after 5th clock cycle, again 0 is XORed with 1, then we are getting 1, and shifting left is going to be shear. So answer is 000 5 ones after first clock cycle. So initially it was 0 0 0 0 0, and it is initial, it is first clock cycle, it is second clock cycle, it is third clock cycle, after 4th clock cycle, after 5th clock cycle. Register contents is going to be, so 000 5 ones. That's all we got till now, the questions from digital circuits, right?
Okay guys, I will going to deal with the questions which are related to the electromagnetic theory. As usual, there is a very good sizable number of questions was asked because this is a core subject for you. Fine. So we will going to deal with the questions which on the data what we have received so far. So here is a question on the waveguides. So it's a very popular question in every paper. So there will be one question on the cutoff frequency of the waveguide. Fine, rectangular waveguide. So here is asking what is the cutoff frequency of the dominant mode. Fine. But the dimensions are given in the inches. Generally we'll take in terms of the centimeters. Fine. So that is the only the thing you should know. So here 1 inch is equal to 2.54 centimeters. So this is the point you should know. Fine. So what is the cutoff frequency formula? It is a very popular one. It is 1 divided by 2 square root of mu naught epsilon naught into 1 by A for the broader dimension. Fine. So convert everything into the meters. Okay. So this is equal to 3 into 10 to the power of 8 divided by 2 into 1 divided by A. What is the broader dimension? It is the 0.28. 0.28 into, I will convert into centimeters, then into the meters. So it is a 2.54 into 10 to the power of minus 2 into 10 to the power of minus 2. Just a second, not minus 2, one more, not one more minus 2. So I'll erase this part here. Fine. So you can check out this one, this value, check out this algebra. So this is around some, this is a formula, but my calculator is showing this value as some. I leave this calculation to you, you can check out. This is around some 21 GB approximately, 21 gigahertz. Okay, check out this calculation. Fine. Next, other question. Yes. So this is something. So it's not purely on the Smith chart, but you should know the properties of the Smith chart to handle this question. Fine. So it is a very nicely designed question, obviously for the 2 marks. So let us try to understand the question here. The complex load is represented as, so it is gamma L is 0.5 at an angle of 30 degrees on a Smith chart. The coaxial cable with the characteristic impedance of 50 ohms is connected to a load. The new impedance of the load now moves to the diametrically opposite point on the
reflection coefficient plane, reflection coefficient circle. So which option is the nearest input impedance of the cable connected to the load? Fine. So let me draw some rough Smith chart here. You should know the landmarks on the Smith chart to handle this question. This is a Smith chart. There is some reflection coefficient somewhere here whose magnitude is 0.5 and at an angle of 30 degrees. If you make a circle out of this, this is called constant VSWR circle. Is asking what is the diagonal point. So if this point is R plus Jx, obviously this point will be here only. Why? Because 30 degrees. Fine. So diametrically opposite one, this will be some R dash minus Jx dash. Why? Because this is a lower half of the Smith chart. The lower half of the Smith chart indicates the capacitive load. Fine. So you can eliminate the one of the option here. What is the option you can eliminate? You can eliminate this option. So the new transformed impedance will have a negative imaginary part, isn't it? Fine. You can eliminate option A. So the answer will be from B, C and then D. Fine guys. So how can you handle this one? So here to here the angle is 180 degrees. So 180 degrees in the sense it is equivalent to lambda by 4. That means, so directly or indirectly you are moving on a transmission line over a length of lambda by 4. Inverter. Fine. So let me turn the page here. So what is the inverter here? The inverter input impedance ZL is equal to Z0 square by ZL. Fine. So you can bring this one here. So the Z of L divided by Z0 is equal to 1 divided by ZL divided by Z0. So it is the normalized impedances here. Fine. So Z of L normalized is equal to ZL normalized. Fine. So Z of L normalized into ZL normalized is equal to 1. Clear? So it's asking what is this Z of L normalized? Fine. So ZL normalized. We'll find out what is ZL normalized. What is the reflection coefficient, guys? It is ZL minus Z0 by ZL plus Z0. Fine. So you can write this one into the normalized form. So Z of L normalized minus 1 divided by Z of ZL normalized plus 1. You can reverse this equation. So it is ZL normalized 1 plus reflection coefficient by 1 minus reflection coefficient. So this is given in the magnitude and phasor form. Convert this one into the polar form. Fine. So it is, so that can be written as 1 plus, I am directly writing, you can check, go through that algebra. It is, so this one is root 3 by 4 plus j 1 by 4 divided by 1 minus here. Fine. Root 3 by 4 plus j 1 by 4. Fine. Okay, done. Now I will directly write it from my calculation which I have already kept ready for you. So it is, you can check out. So this one is ZL is equal to 1.43. You can go through this algebra. It is 0.25 divided by 0.56 minus j 0.25. Fine. So multiply this one with this ZL normalized. ZL normalized is R dash minus j x dash. Fine. So ZL normalized into Z of L normalized into ZL normalized must be equal to 1. Fine. So that means R dash minus j x dash into 1 plus 43 plus j 0.25 divided by 0.56 minus j 0.25 must be equal to 1. Okay, you can bring this one other side. So you can separate out the real terms and imaginary terms. I will not going to do this algebra. I will leave this algebra for you. Just it is a 2 more minutes it will going to take, but I will not going to do that. So you can solve those 2 equations, 2 unknowns. I leave it that one to you. So you will going to get R dash is equal to 0.35. What is this R dash, guys? So this is R by Z0. Fine. That means normalized value. So what is this R? R is equal to 0.35 into 50, guys. So you can check out, this one will be equal to 17.7. This is enough. You can answer. You no need to find out imaginary part. Go back 17.7. So here, so obviously no other option is having the real part as 17.7. So obviously answer C will be the answer. Fine, guys. So very interesting question this is. So he has given the direct, he has not given the direct data in the question. He has mentioned the indirectly that the transmission line is having a length of lambda by 4. That he has not mentioned directly, so he has mentioned that one with the help of the Smith chart. So very nicely designed question this is. Obviously this is for 2 marks. Fine. Let us handle one more question here. So this is obviously 1 mark question. Fine. So this is on the definition of the loss tangent. Generally how the loss tangent is defined? It is defined by definition. By definition it is tan delta is equal to magnitude of the conduction current by magnitude of the displacement current. Fine. So this is equal to sigma by omega epsilon. Okay guys. So what is this? This also can be defined in other way. Gamma is equal to square root of j omega mu into sigma plus j omega epsilon. You can write this one as square root of j omega mu into j omega epsilon. Fine. It is 1 plus j sigma by omega epsilon. Fine. So this entire thing we'll call it as the imaginary epsilon is equal to epsilon into 1 plus j sigma by omega epsilon. So this is equal to epsilon plus j sigma by omega. Fine. Okay, this is epsilon dash. So it is epsilon r dash is equal to epsilon r plus j sigma by omega. Fine. So if you take the ratio of these two things, then also that will going to give the loss tangent. Fine. So how, what is the other way of defining the loss tangent? Generally this is represented with the epsilon dash. This is epsilon effective. Okay. So this is epsilon double dash. So this is also defined by the real part by imaginary part. Okay guys, fine. Now come back to this question here. So it is ratio of real to the imaginary parts of the total displacement current. You can actually eliminate this one. No, it is not defined like that. It is defined like ratio of conduction current to the displacement current. Next one, the ratio of polarization vector. No, this loss tangent is nothing to do with the polarization. Susceptibility. Fine. You can eliminate this. So the ratio of susceptibility. No. Fine. So obviously this will be the answer. But let me justify how this is answer. Fine. So obviously, as I said earlier, generally what is the loss tangent guys? Tan delta is equal to imaginary part by real part. What is the imaginary part? It is the epsilon dash by epsilon. Real part by imaginary part. So real part by imaginary part. This is one thing. This is due to dielectric medium being complex, isn't it? So if the dielectric medium is a complex, so that will going to contribute for the loss. That is the one aspect. The other aspect is if the medium is having a conductivity, then also that will going to contribute for the loss. Fine. So that is what he mean from the question. Fine. So of course in the we do not have any information regarding the question, how the question was framed, but this is the essence of the question. So he must have he must have mentioned what these symbols epsilon double dash and epsilon he would have mentioned in the question. Fine. So just we have got only the essence of the question. So from those assumptions, so this will be the answer. Fine. So this is a loss due to the dielectric being a lossy one, and this is a regular one because of the conductivity. Fine. So if you just add up these two things here, what you're going to get? Imaginary part by real part, you can check out. So this will be equal to the tan delta. You will going to get the first term. Yes, omega epsilon. Notations we do not have a clarity regarding the notation, but this is the essence what we mean to convey. Fine guys. Yes. Anyhow, so obviously option A will be the answer. Fine. So we need to get a clarity regarding the notations. So that is the reason why. But concepts point of view, the essence, the gist, what we can conclude is option A is the answer. Fine. Anyhow, yes. So this is a very straightforward question, guys. Yes. Here is a question is asking for the polarization. So here the magnitudes are obviously he brought a magnitude outside, so the magnitudes are same. And here cos and sine, the phase difference is plus or minus 90. It is a circular polarization. Fine. So check out the circular, linear is not answer. Right-handed circular, left-handed circular, linear polarized. You can eliminate option D also. Answer will be from B and C. Fine. So let us try to decide whether it is the left or right. So for that, we need to make this Z is equal to 0 here. Fine. So if I make the space 0, you will going to get E is equal to, I am writing in a very precise way, E naught into cos omega t x cap plus E naught into sin omega t y cap. Okay guys. So let us take at the two different points. At time t is equal to 0, omega t will be equal to 0. Fine. So the E is equal to E naught into x cap plus 0 y cap. Take at one more time instant. Fine. So during my lectures also I told that this is a very popular one, and even the waveguide concept also, waveguide cutoff frequency, those things we were very damn sure about them. Fine. So fortunately we got the same questions. Fine. The only thing is the dimensions was mentioned in the inches. Fine. So that is a trend we are noticing. So fortunately this year also we got the same. Fine. Anyhow guys, let us try to decide what kind of orientation is this. So this is a x, this is a y, and this one is a z. Z is coming outside the board. At time t is equal to 0, resultant is on the x axis. As the time progress, positive x, positive y. So here is a resultant. Fine. So if you frame a vector from here to here, so if you put your thumb in the direction of the current direction of propagation, why? Because the wave is traveling in the positive z direction. Fine. So if you place your thumb in the direction of wave propagation, your right hand fingers are in the sense of rotation. Fine. So what kind of polarization is it? Right-handed circular polarization is the answer. Clear? So what is the answer guys? Option B is the answer. Fine. Yes, it is a very interesting one. Some extra data is given which is not required. Fine. So for a lossless passive, you said lossless passive two-port network, S11 and S21 intersect at minus 3 dB. Intersect in the sense obviously they will be equal. Fine. For a lossy, that is for lossless, and he has given the information regarding the lossy also. Lossy passive port network S11 and S21 intersect at minus 4 dB. Fine. So the percentage of power dissipated in the lossy network at the intersection frequency is, see, these S11, S22, those are the, how they are defined? They are defined the fields magnitudes, isn't it? They are reflection and transmission coefficient. They are defined for the fields, electric fields and magnetic fields. Fine. So incident voltage waves and incident current waves, like that. So when you are dealing with the voltages, currents or electric and magnetic fields, it is the 20 log. When you are dealing with the powers, it is the 10 log. Fine. So what is this S11 guys? So it is a 20 log. Magnitude of S11 is equal to 20 log magnitude of S21, which is equal to minus 4 dB. So from here you can find out S11 is equal to S21, which is equal to 10 to the power of minus 4 by 20, which is equal to 10 to the power of minus 2 by 10. Fine. So S11 is equal to S21 is equal to 10 to the power of minus 1 by 5 or 0.2, one can say. You can write here it is 0.2. So I will check this value I've already calculated here. So it is a 0.63. Fine. So these are the, as we all know, S11 is a reflection coefficient. Yes, it is a transmission coefficient. S21 is a transmission coefficient, isn't it? Fine. If you think this as a, this is a port 1, this is a port 2. Fine. So these are reflection coefficient. You are feeding the input at a port 1, observing the output at a port 2. So these are transmission. So whatever you are feeding to the junction, what happens? Some part will get reflected back and remaining part will transmitted. Fine. If at all if there is any loss exists, some part will be, some dissipation happens in the junction. Fine. So in the question itself it is mentioned that it is a lossy one. Fine. So obviously what you are feeding, some part will get reflected back, remaining part will get transmitted, and leftover one will be wasted in the junction. Fine. So here one can say what is the loss, guys? The P loss. Fine. The P loss is equal to, as we are dealing in terms of the coefficients, it is a 1 minus. How much got reflected? Remember, these are the voltage ratios or current ratios. You want to power. Fine. You have to take the square of that. So it is a 0.63 square minus. So you are removing this transmitted part and reflected part, so that will going to give the remaining loss part. Fine. So it is 0.63 square. So this is a reflected one, this is a transmitted one. So the P loss, you can check out this calculation. So my calculator is showing it as a 0.22. Some extra decimals are there. Fine. So here he is asking in terms of the percentage, the P loss. Maybe this may be a numerical answer type question. So it is a 22 point something, 22.4 or something. I leave there. Okay, guys. Fine. So yes. So this is all about that. Any other question? In my knowledge, there was no other question. Fine. So the question was very direct and straightforward. Only one question, that Smith chart question, was also indirect data was given. Fine. See here, just to give you some kind of motivation or attention or some kind of a solace for you guys. So we have collected the questions from our students. Fine. So who have attended these exams today. Fine. But remember, this is not the final one. Don't get discouraged. Okay. Be focused. So the good thing yet to happen. Fine. So in a couple of days, we'll going to come up with a very precise, profound and sophisticated solutions for a given, for the question paper what we're going to get. Fine, guys. So have a hope. Don't leave any hope. Fine. So that too, today is a very precious day. We are having a Mahashivratri. So everything will going to be in our favor. Fine. So good luck. All the best. May God bless you all. Thank you.